Welcome to the show, Frank. Please take a moment to tell us a little bit more about you and what you've been up to of late.
Cool. Thanks, David, for having me on, first of all. For everybody out there, I'm Frank. I'm currently a staff engineer at Personio, which is a big HR company based out of Germany. I joined Personio about a year ago. Before that, I did a couple of years in fintech, which gave me a lot of appreciation for the sort of more consistent side of things. Like losing a transaction is not something a fintech really accepts. So especially in sort of larger distributed systems with many systems integrating, often with events and messages. That was a really interesting experience. Before that, I did a lot of work for the Schiphol, the airport here nearby. Did a fully event-driven real-time dashboard application for their internal operation with highly sensitive data. That was in TypeScript, and for the rest, I've done a lot of stuff in PHP. My current day job is more with Kotlin, so for the languages or whatever. And so I've been doing this for a while now. I think close to 15 years of doing this stuff. So yeah, and I'm looking forward to doing it at least 15 years more. So, yeah.
Awesome. All right. Thank you for sharing. So yeah, I kind of, I've followed you for a while with Tachi before in the past, and I knew you from the PHP ecosystem, but I did see that you were doing Java and Kotlin and now TypeScript as well. I think it's always interesting that the more we do this, the more the language becomes less important, right? And it's more about all the things you learn along the way. So hopefully we'll get into that in more detail as we go through the episode.
Yeah, I totally agree, right? So you see all of things sort of lumping together, and doesn't at the end doesn't really matter what tool you use anymore. But it also means that you're going to encounter the same problems in different flavors. Yeah.
Yeah, or rewrite the same library 14 times in all the languages that you're going to work with.
Well, I have written or rewritten Event Source, which is an open source library that I maintain. I've rewritten that in a couple of languages now, which is always an interesting experience because while the majority of the things that you do sort of maintain or they are the same, but some things you really adjust towards what kind of language mechanics you have. And that's always an interesting route to explore whenever I'm doing that in a new language.
Yeah. I mean, I have the first question all panned out, but I'm going to skip it right now and just go down this little path where we're talking, because one of the things I found most important in my career, and I think you just kind of alluded to it there as well, is that when I wrote C, I learned how to write C code. When I did PHP, I learned how to write PHP code. When I did Elixir, I learned how to write Elixir code, and so forth, right? Go and Rust. I love experimenting with languages. But what I love more is learning from the idiomatics of each language. Like concurrency in Go is very different from what I've done in PHP. Concurrency in Elixir is very different to Go as well, because it has this actor-based process model. And it's just through the combination of all of these different idiosyncrasies, I don't even know if that's the right word, of each of these languages and runtimes, but you build up a different picture of what software should look like in your head, regardless of the language. I don't think I would be the developer I am today if I hadn't worked in all of those languages and learned all of the different things they do different in their ecosystem. Does that make sense?
Absolutely. One of the first conference talks that I ever did was at Laracon, I think in, when was this? 2012 or something like that. And it was a talk called The Knowledge of Others. And it was basically a talk about looking at various ways at solving a problem. And during the talk, I sort of looked at different types of problems and then looked at what languages are most likely to solve that problem. So, for example, in JavaScript, you have a lot of sort of in-process event-driven stuff. So I looked at hey, what does an event emitter dispatcher look like in JavaScript, and how can we sort of get the same kind of capabilities in, for example, a language like PHP, and also what's missing or what's not fitting very well, and how can you overcome that? Like, I think that's a very interesting way of looking at it. But you look at these languages and how they frame it, and the idiomatic solutions always provide a certain type of framing, right? So for Go, like you mentioned, Go, I think the model of concurrency there is very interesting to look at, and it's very like or the way that I did it at least was very channel based, right? This is what Go, the programming language, right, really promotes, and they've got a very strong sense of how you should write code like that. And using stuff like that in like trying to replicate that in different languages is sort of an interesting exercise. It doesn't always play out, but you can definitely take some learnings from one idiomatic approach and apply it in a different space. If anything, it's a lot of fun.
Yes, I will 100% agree with that. And I have taken a note about the knowledge of others Laracon talk. So I'll make sure there's a link to that in the show notes if I can find that online for people to check out. Plus, I kind of want to watch it myself. So.
Well, I don't think it's probably not my best talk ever. Like I think it was one of the first talks that I ever did in public, and I actually don't remember a lot of it because like being on stage, especially at that point, was like such a sort of high intensity, high stress moment that my brain blocked the majority out. So mind you, the quality might be not what you expect it to be.
Awesome. All right, let's go back to the planned first question then. So obviously we've discussed event sourcing before. You've already mentioned event sauce, your library. You've now written it in multiple languages, and it's a great way for people to get started with event sourcing. But what I want to understand is, how did you even end up in this event-driven architecture ecosystem? What led you from writing, your PHP and just writing web apps or whatever it was you were doing back in the day to going, oh crap, like I want everything to be event-driven? What was the path like for you there?
Well, so I was very fortunate enough to work on a couple of projects where this was just needed. Like the only way to do things was an event-driven way. The first project where it was really relevant was the website for Schiphol. And so that was still in sort of the website-y area, but it got a little bit more complex with some logic there. But effectively, the way that we had to ingest flight information needed to be as close to real time as possible, right? So as soon as possible view on what the planes were doing. As a customer, you wanted to know, like, hey, I'm going on a KLM flight and I'm going to London. What's the status of the flight? I want to, in my web app, follow that flight, keep track of it. And whenever something new is up, I would want to see that. Now, the only real way to do that for the scale that we were at, like doing that for all of the passengers that go through Schiphol, you can't do that on a polling basis and then figure out the delta between all of the flights that are there everywhere, right? So one, it's not efficient enough, but it's also not quick enough, right? You want it as soon as it happens. So we built a whole event-based integration there, and that was really on the consuming side of an event stream. So I would say that's a relatively comfortable way of starting out in the event-driven space is to be a consumer of events, right? So you can sort of skip the whole how, when, and in what form should I be producing this, and just see it as a stream of information that you can respond to, that you can create projections from, and all that. So that was my sort of initial introduction into the event-driven space, which was soon followed by going into the event-sourced space. For this same airport, we created a way to book parking spots for Schiphol, which for an airport is a huge revenue stream. And so it being a huge revenue stream, you also want to get a high level of insight into what is going on and why things are going the way they are. So, for example, if you're booking parking spots, you get multiple types of parking spots made available for you, which are at different price ranges. So you also want to know, as a vendor of these parking spots, like what does the positioning of those parking spots do for the general choice of the parking spots afterwards? right? So you can do this with just an API call and record the response, then track where you positioned it, and then do a separate call afterwards to say like, hey, which one was picked. But it's very indirect. And a more direct way is to just record that all of as events and then make sure that you use those events to gain those insights along the way. There, I was very fortunate to work with Marijn Huizenveld, who was doing event sourcing, like I think maybe even before I started programming. So I had a veteran of event sourcing as a mentor and as somebody who guided that entire project. So I was very much in a following capacity when I was executing that. And Marijn was really leading that effort there.
Nice. Well, yeah, I got a couple of questions, right? So you kind of mentioned event-driven and then event sourcing. And, to the people that are listening, I'm going to ask you the same question twice, but for each of those. And you can just say yes or no, or you can give more information if you want, right? But would you say that most applications could benefit from adopting some event-driven aspects?
Yes.
Right. What about event sourcing? Is this what the question I'm really getting at here is? What is the decision? What thought process do people need to make before they say, yes, I'm going to bring event sourcing into my application? Can they do it for all applications, or is it a very specific requirement need? How do you make that decision?
Yeah, for me, it needs to be the core business that you're modeling. And there needs to be I like it when there is a temporal effect to it. So multiple things happening after each other. There's a sequence to it. And what happens is sometimes as interesting as the state that you end up with. So if you compare it to CRUD applications, right? CRUD applications, you have a state, something happens, you overwrite something, you have a new state, you overwrite the past effectively. This also means that you lose that state, right? So you forget about the past, but you also forget the delta. With event sourcing, you store everything that happens as a general principle as events, and then you just append those events. So this also means that you retain all of the information over time, but you also retain all of the delta. In fact, the thing that you retain is the delta. So you're always able to get from where you were to where you are now. And there are a couple of benefits to that, which some problems are more prone to benefit from than others. So for example, if you have changing policies and those policies need to be applied even though something was vetted through the process before and was deemed okay, now a new policy is added and no longer valid. How do you deal with that, right? Having that stream of events and not just the outcome of something is valid, yes or no, right, is useful in such a case. If you're doing something that's purely CRUD, right, I need to have an inventory, or I need to have, a user management, all of those things, probably not useful because you're only interested in really the current state of things, like how things got there. You don't really care about it. Permission management, right? You don't care about how the permissions got to the state where they were, but you care about what your current permissions are and how to apply them. So not all problem areas really benefit from it.
You got to understand your domain to the point where you understand there's value in those missing pieces of information that we purge with a standard CRUD-based operating system. I kind of understand that, right? Yeah. But then by saying that we wouldn't adopt event sourcing for a CRUD application, I think what the subtext is saying there is that there's a cost of adopting event sourcing within your organization. Yeah. It's not, it's just 4 lines of code and I've got an event sourced application anymore. So I'll come at this from 2 different angles then. It's like, what is the cost? Why is it challenging for people to bring event sourcing into an application, to their team, to their organization? And part 2 of that is, well, what is there a future where event sourcing becomes more of a commodity, where it is easier to bring into a project without that cost?
Yeah. So there's definitely a cost to it. I would argue that the cost is mostly misinterpreted or misassigned. The biggest cost is probably that on people. So if you're looking at experience for CRUD-based application development, it's there in abundance. If you're looking at the experience in building event-driven architectures, there are still plenty, but it's a lot fewer than like finding people who can build good CRUD applications. Where people usually attribute the cost of event-driven architectures is saying like, hey, now I need a queue, now I need all of these background processes, now I need all this orchestration. And I would just say like that's not inherent to event-driven architecture. So you can do event sourcing, which is a very event-centric approach of modeling domains. You can do that in a single-threaded language like PHP without a queue, right? You can do in-process consumers where the events that you record are passed in the same web request to the consumers that project their state, send their emails, send out API calls to other kinds of services. That's all possible. Is it ideal? No, but it is a good starting point, right? If you have a tiny application that needs to do a couple of things, reliability is not yet a big concern, then you can really reduce the cost by turning down all of these levers, right? You don't need fully fault tolerant everything at the start of a project, right? So, yeah.
Okay. So let's pivot the question again, one more degree. You've got this team of engineers. You're on it, right? You're kicking ass. You've built an event-driven system before. You've got event source in 2,000 languages. Anybody can build event source applications nice and easy. Would you, personally, just you, if I came across and said, I have this really simple CRUD-based application or microservice that we need as part of our larger application, at that point, is it easier for you to do it with event sourcing, or is there still a cost for you to do it? Like, I'm wondering, if I have the experience, if we have a team of experienced people, like, would you default to event sourcing, or would you go just credit?
No. So defaulting to any type of technology for me always sounds like a very dogmatic thing to do. So you need to balance it with like the benefits of implementing something and the costs of it. And so especially when you have a large team around you, if you don't have any event-driven experience within a company, then you're saying like, hey, we're going to change this core component and we're going to switch it from a more CRUD-based to a event-driven approach. That has a serious expense to it. So it's more that the expense is that the organization will need to learn about event-driven architectures, and that means that they're going to fail at it for some time. And so you need to find a mode within the company that they're able to fail. And sometimes the expense is high, but even then it can be okay enough to do it. So for example, in some systems that I worked on, all of the adjacent business processes were taking direct database access to the columns that they needed to get their information from. Well, this also meant that it was very difficult to change that system. So by introducing events, we allowed these secondary business processes to decouple from those internals, giving the internals the freedom to change, right? So because this was a very necessary change for the system, the rewards were higher than the cost, right? And so in those cases, you can do that. But you need to have seen sort of the other side in order to make that assessment. And that's sometimes difficult, right? If you have decision makers within the same company who haven't yet seen that benefit, and then it's hard to sell them based on the claims and the merits of those solutions.
Yeah, I love that you mentioned the failure aspect there. I think what a lot of people often forget is that people with experience or people that are good at writing Kotlin, that doing Kubernetes, at building microservices, doing event sourcing, they weren't magically good at it because they've done it lots. They're good at it because they've done it wrong more times than anyone else, right? And teams have to build up that competency. And sadly, the fastest way to do it is to get a lot of shit wrong. So.
Yeah, you have to sort of like eat dirt, get up and continue.
All right. Now, we've chatted for like 20 minutes now, and we haven't really tackled, for anyone who's new to event sourcing, CQRS, and event-driven architectures, a kind of overview. Now, we have covered a little bit of it through your conversation. You've talked about squashing or losing history and maintaining history and stuff like that. But maybe we could give people a quick 5-minute overview on EDA, event sourcing, and CQRS and how those work together.
Yeah. All right. I will start with event sourcing. So event sourcing is really a way to model problem domains where you're using events as the primitive to record what's happened, so to store state. In event sourcing specifically, you also say that the state that you use in order to base new decisions upon are in essence sourced by the events that you record. And this usually means that you reconstitute your domain model by reapplying all of the events of the past, putting you in the condition to make a decision that will then again result into a newly recorded event. This is different from traditional entity-based and state-based modeling, where you overwrite the past. A reason why this was introduced is effectively for not losing the history that you have recorded along the way. It's very inspired by accounting. If you have a bank account somewhere and you deducted too much money somewhere, right? You don't get that row adjusted. You get a counter transaction that says like, hey, I'm going to file a correction now. So, for example, I overbooked some money. I removed 120. But I meant to deduct 100. Now I'm going to sort of reimburse you 20. We all know how this happened and how we got to the end state. We know how the correction happened. Well, for some business processes, this is really important to have as context. Now, that's sort of event sourcing in its essence. So sometimes it helps to relate back to other primitives to sort of see how it really works. I usually say like, hey, an aggregate, which is what, or an aggregate root, which is what you refer to in event sourcing terms as the entity, is sort of you have a stream of events and you sort of map reduce those events into a state. You use this state in order to provide the context for your next decision. And then afterwards are more events, and that's what you get out. The benefit of this is that it becomes really deterministic. If you have state-based applications, you need to set the state, and whether that state is something that you would end up in or not, right? That's out of the question. And then you need to make a decision, and then a new state is what you actually assert on. In event-driven systems, especially event-sourced ones, you can have a really nice given when then structure, which says like, given these events, when I do this action, now I expect these events to be recorded. And that's very deterministic. It's almost like mathematical in that sense. You can sort of see that as a proof of the system working without having to manipulate any inner parts of the system. So that's very nice. So I think, does that sort of clarify the whole event sourcing part?
Yeah, I think that was spot on. I'm going to add one example that I found really useful. I can't remember who it was. It was either you that told me it in the pub, or maybe it was Greg Young on one of his talks. But it was the e-commerce example, where if you think about building an Amazon and someone adds something to a cart and removes it from the cart, and they do that 5,000 times and then they buy one item, there's 5,000 items there that you can upsell them later if you track that they added it and removed it from the cart. And that was the one, and I still remember that example clear as day today. It's the one I went, oh, there is a lot of value in some of that information that we've always purged in the past.
Yeah, I think one of the situations that I think is often underutilized, even in event sourcing, is recording of failure. So if you, for example, want to pay for something, but you have insufficient budget, right? In a entity-based system or a state-based system, right? You say, I'm entering the method. Do I have enough balance? If no, throw exception. If yes, mutate the state. So only then it has effect. Within the event-sourced system, you might say, go into the method, see if there is enough balance. If not, record an event and throw an exception. And you always store any type of event that you record. So usually you put that in a try and then finally block, where even if there's an exception, you store all of the recorded events. And all of a sudden, you have insight into all of your unhappy paths, right? So you can capture the context of the failure. And that's really like where you see the users have friction with your product or with your business process or anything in relation to that.
Nice. Great example. All right, let's tackle the next one then. So CQRS.
Yeah, so CQRS, I'm bigger on event sourcing than I am on CQRS. So CQRS, I often see, or when it's talked about in the community, it's talked about applying it in a very dogmatic way. Right? So you have to separate everything that's an instruction to the system, so that tells the system to do something, and the other part is really how to get information out. The reason they want that is to allow for different models on how you query that data, which are optimized for querying, and the decision model is not necessarily the best model to also query it. So for example, if you have an order-based system and you want to aggregate how many orders there were today and what their cumulative amount was, right? You can do a sort of SQL aggregation over that, but it might not be very efficient if you have a large amount of customers, right? So using events to then say like, hey, I'm going to record all of the events of the purchases, and then I've got a secondary model, which is the accumulation of all of the amounts that were stored for a day. You have a sort of a live view of what that means across the day. And querying it is just basically querying a column within a database, right? Very efficient. And so there's definitely value in separating out these models, but always doing that, right? I think lacks a bit of nuance in that sense, right? For many of the problems that you have, the original decision model has enough data points that you can use for reads. And also always doing it, how do you say this? A lot of people applying CQRS also say like, hey, then you put it on a message bus. And so that means that the state that you want to query maybe in the same request is already eventually consistent, right? So then you need to deal with that fact again. So, people create all kinds of ways to work around that problem. So one is like your aggregate has versioning, and now your projections have versions as well. And you're just going to pull the read model until you get the right version if you want to get the response for that version. Right? That's a possibility, but it's also very cumbersome, right? So you get some dogmatic things like command buses shouldn't return any values and all that shenanigan. Like those shenanigans, I think is too dogmatic. So I think as a pattern, like being able to separate those things, fine. Always doing that, I don't really see the value in that.
Okay, let's touch on one more thing and then we'll move on with the questions. But you've covered event sourcing, great. CQRS, perfect. So if we have all of these events, we have to build projections. We have message buses. A lot of what we're saying here, right, kind of maps to what I'm seeing in a different ecosystem, which is cloud native Kubernetes, right? We're seeing microservice adoption, which is being built on event-driven architectures, where people are preferring to do publish events to NATS or Kafka, RabbitMQ, etc. And all of these services are independent, right? The goal is to be loosely coupled. And it feels like there's actually a lot of crossover and benefits to both of these architectures maybe working together. So I'm curious if this is something that you've seen a lot of from the event sourcing ecosystem. Are people doing microservices? Are projections of microservices? Like how do these two different tangential things work together or correlate?
Yeah, so I think they're just the same thing at a different scale, right? So if you've got a monolithic application that is recording messages that it's consuming itself in order to record state as a projection that it's serving on a different REST endpoint, that's for me the same as two services which there is a dependency between, where you have a source system for information and a dependent system, and it's using messages to be kept up to date, right? So in essence, it's the same thing, but then scaled up and maybe with a higher infrastructural cost associated with it. But in principle, it's just the same. The thing where it deviates is in the coupling and knowledge area. So if you have two different services, you know that the services have a different level of detail regarding a particular subject. So if you're in a monolithic situation where you're the consumer of the events, you tend to have a high level of detail and a high level of volatility of the information that you're consuming. So if you're modeling your business processes with events, then innovating on that business model means changing events. If you're doing that for yourself, you're exposed to your own volatility, right? So that means that you need to, if there is a new version of something, you need to account for the backwards compatibility, at least for the period where you're exposed to those changing events. Now, if you amplify this to the microservice world, this volatility means usually that you're going to be disrupting other services unless they accommodate for this change as well. And especially in larger organizations where those services are not maintained by the same people, this is where you get up into shit creek area, right? So if you're changing the event stream that somebody else is consuming and you're not informing them and allowing them to accommodate this in some way, shape, or form, you're going to cause a disruption in production. And so that's more difficult. Now, luckily, there are patterns to deal with it. But this usually, like you asked before, like, hey, what's the cost of introducing event-driven stuff into projects? It's learning this and learning the ways to deal with it. So in event-driven architectures, usually say like, hey, just expose everything, right? So as a first iteration, I've got all my internal domain events. Well, now they're all external domain events and everybody can listen to everything. Now I want to change something. I've done the whole integration part before. Now I want to change anything. Now I need to change all of my integrations, right? And so while event-driven architecture is usually attributed that is great for decoupling, unless you do that on the information level, you're still just very highly coupled from business process to business process. And you still need to do sort of diligent information disclosure and deliberate information disclosure in order to prevent that, right? So within object-oriented stuff, we say, well, we've got an interface and then you can touch these public things, but you cannot touch these private things, right? Within event-driven architectures, especially if your implementations mature, you see the same effect, right? You've got internal information streams and you've got external information streams, and you act differently. With object-oriented, you say like, hey, I'm maintaining sort of a backwards compatibility for a large degree, and sometimes I'm creating APIs with a new version, right? That same applies to event-driven architectures, but then you're accommodating that by versioning the payloads that you send, and then putting anti-corruption layers in place, which are either on the producing end or on the consuming end, that smooth over the differences between these versions. So that means, so for example, if you are producing a new version of your event, which has more fields or fields that are just formatted a little bit different, something that's really backwards incompatible, then what you can do is have sort of a mechanism on the producing end that says like, hey, I'm going to consume this stream and I'm going to convert it to the older version and publish that as well. And so a mechanism like that gives other parties a lenience period where they can still rely on the old information stream, but then also have at their disposal an event stream, which they can consume in parallel and then try it out for a bit and then convert all of their integrations without needing to do it as a hard cut.
Yeah. Can I just confirm something there? Because that was really interesting to me personally, right? Because versioning is hard. And when we talk about challenges of this, I'm sure versioning is going to be one of the biggest ones. So maybe we'll come back to it. But I never really thought about publishing or having a producer who already has all the knowledge of the versions, right? Because it's their domain. Do you publish them as separate events with the different versions, or do you like wrap them in an envelope and publish them as one event with multiple versions as a payload? Like how does that work in practice?
In practice, it's so if you need to couple them in the same message, they need to be produced atomically, right? So thinking of this a little bit longer, I think you can do it like that, even if the producer doesn't produce them both versions. But what would the benefit be?
Well, I was thinking if the producer emits version 3 of an event and it has a function to downcast it to V1 and V2, wraps them in an envelope and publishes it, then the consumers can kind of cherry pick out the version that they understand the most, or the latest version that they react to it and handle it. But then I guess you also want downstream to be working to the latest version too.
Yeah.
Tough problem.
So that is possible. You would be publishing multiple versions of the same event inside of the same event stream, right? So what you sometimes have is that upgrading event versions or entire streams, they're used as an opportunity also to re-provision all of the infrastructure that's behind it. So if you need more topics on your Kafka stream, right, having a new stream is sort of an opportunity to say, like, hey, I'm going to over-provision a little bit again. So I've got some breathing room for my concurrency for my consumers. So usually you want to have that as a possibility. Now, a consumer will rarely, in one business process, consume multiple versions of the same event, right? So usually what you do as a consumer is you're going to put side by side multiple consumers that do version A and version B side by side, and then you can sort of compute, like if you want to do a parallel run, you can check for differences afterwards. So they just have one thing. So you can certainly do it. I've never seen it being done like that. So usually what you see and what I think is idiomatic in that space is that you have either on the same stream, you have that payload of multiple versions. So you have a type and a version of the type, and it's published over the same stream. Or if the entire stream is being upgraded from one version to another, which is usually the case if the structure of the data or the payloads are fundamentally changing. So either there's something changing in the envelope. That's usually a case where everything bumps up one version. Then you see more often that an entire new stream of events is being introduced for those cases.
Nice. Well, it feels only fitting that we're talking about some of the hard stuff then with event sourcing, that we maybe see, are there any other challenges that you've faced adopting event sourcing at Skipple and other places that you want to share with people? Like, you know, assuming some masochist listening to this podcast has went, you know what, this sounds really cool. Hard, but really, really cool. Like, what else should they be looking out for? What else have you worked through?
Yeah, so one of the areas where it's both a virtue and a curse to have event-driven architectures in place is disaster recovery. So as soon as sort of metaphorical shit hits the fan and maybe you have catastrophic infrastructure failure and the consuming system loses all of their state, they need to rebuild that state from somewhere. So in more state-based systems, you either work off of maybe a database replica or something else. You sort of ingest or restart that whole replication process. With database native technologies, you're in place relatively quick. For event-driven architectures, it can be more cumbersome and you need to design for it. So, for example, if you've got a projection and you need to recreate all of your current state based on everything that's been recorded before, the question is always like, how far back do you need to go in order to figure out what to reconstitute from? Are you going to do that from the epoch of your business, right? From day one of your business? Or are you going to have some intermediate state where you're going to say like, all right, I've got a snapshot of the state that it was at, and now I'm going to reconstitute from that point and out and reconsume. Now, that is not something that is very trivial to design for. And you need to apply a couple of sort of supporting practices which help you to do that. I think Kafka as a technology makes it easier to do some of those things, mostly because they have a incremental offset-based storage strategy where you know where you left off. And if you have a snapshot that's at a particular Kafka partition combination, you can take that state and know, all right, I was exactly there, and I can go on and reconsume the rest. If you don't have such a system and you have got your own sort of like delivery mechanism, if you're going through RabbitMQ or any type of other like sort of transient message queue implementation, right? You need a way to inform the producer of those events to reflush whatever they had. So reconstitution of these read models becomes a lot more involved. So it's not all cherries and rainbows in that sense. One of the things that you can actually do is use your partitioning strategy and your log compaction strategy on Kafka to always ensure that all of the leave nodes retain the latest bit of information. And if that fits your domain model, then you can use that as a way to quickly get to the latest state of everything. Because effectively on all of those partitions, you guarantee with like every key, the last message of that key contains the last state that I'm interested in order to get to the current state. But that's very much like in the details of your implementation already. So there are opportunities there, but you really need to understand whether those solutions really match the problem space where you're applying it in. And that's not always the case.
Awesome. All right. I'm not sure how many people still want to build event source systems after hearing that, but it definitely is. It's fun. At least you.
Well, so sometimes you don't have a choice, right? So for example, if you have a source system which is unreliable and you have a high value system that's dependent on it, right? Are you going to accept the downtime of this system as a limiter for your value creation stream? Like, no, right? So you want to be kept up to date with the latest information. So yeah, you're going to swallow some of those costs and difficulties that are associated with event-driven architectures. Usually just trading one bag of problems for another, where you hope that the downsides of those problems will affect you less and that the upsides of having done that will reap you more benefits.
Exactly. The classic answer, it depends, right? Like you got to pick your trade-offs. You got to pick which level of complexity you need for your application. And event sourcing has a very interesting and applicable and useful and value add in some domains that you really need to go down the rabbit hole.
But definitely not all.
Yeah. All right. Well, I'm curious then. What are you excited about these days? What new shiny things are you playing with, experimenting with, or even just interested in you've not had time to play with yet? Like what's in the future for Frank?
So I'm curious to see if we on the sort of real-time aspect of ingesting data, there's a lot of experience that I have in implementing that. The one area where I have a lot less experience is on the controlling side of it, right? So real-time interactions with systems, which can also be message-based from. So imagine you have a React UI, and that's not a blog or another type of simple information system, but more like a system that you really interact with hands-on to see hey, how can you interact with that system in real time and then get real-time responses out. So I know that PHP is not really a language where that's super easy to do. In the sort of TypeScript Node world, there's definitely some precedence for that. And in the Java, JVM ecosystem, there's also a bit of that. But I also want to learn more about Rust. So maybe I'll just use Rust as my next language to experiment with and implement that. So that's a general area, but it's still really fuzzy for me in terms of hey, what does that really look like? And what type of systems can I study in order to learn more about it?
Sweet. All right. Well, I'm looking forward to seeing event source and Rust then. I think that's going to be a lot of fun for you to work on.
I'm guessing it should probably, if I'm looking at Rust, it probably involves some kind of macros somewhere.
I mean, you could write some really sweet procedural macros in Rust to handle the replay logic within a struct. I think that would be super cool, and everything would work within an implementation block. I think the developer experience and the API you could provide for event sourcing in Rust would far surpass any other language.
Yeah, all right.
Because it has really great macro support. Metaprogramming in Rust is good. Metaprogramming in Go,
not so
much.
No, no. In Go, there's some awkward bits if you need to do event sourcing there, because it's very difficult to do anything very dynamic, and event stuff is usually benefits from some dynamic forms of programming.
We'll go to that generic support in 1.18 or 1.19. So I think that landscape is now wide open for some innovation, but certainly prior to that, it's been tedious at best. So This has been awesome. Thank you so much for spending the last hour of your life sharing your event sourcing journey with me and loads of interesting information for people listening at home. I'll now give you just a minute if you want to share your Twitter handle, plug your website, your company, open source projects. Now would be the time to plug away.
Cool. So if you have any file system needs within the PHP ecosystem, check out Fly System, which is the main PHP file system abstraction library. If you need to build anything event sourced also in PHP, check out EventSauce or check out eventsauce.io. Check out my employer. They're called Personio. If you're a company that needs to work with HR processes or any other type of HR tooling, that's what they provide. So do check them out. And when I have the time, I blog on my personal website, which is blog at frankdejonge.nl.
All right. Thank you very much.